Okay, welcome to the guide sheet video for forces and motions in two dimensions. This is guide sheet number 2. We're talking about how we add vectors. Mostly we're concentrating here on adding vectors in 2 dimensions, but to do that, first a quick reminder of how we add vectors in 1 dimension. Again, a vector is a measured quantity that requires both a magnitude and a direction. Up to this point, we've been able to deal with our vectors, examples of which are displacement, velocity, acceleration, and force in 1 dimension. Now that means if I had 2 vectors, they were both working along the same direction, same dimension. Now in this case, they are working together, so I would add them together, and their resultant overall vector would be the combination of the 2, which would be a vector from here to here. So we call that the resultant. In other cases, we had vectors that were working against each other. If they're working against each other, then when we add them together, it's going to look something like this. So if this vector is working against this vector, then the resultant, the amount that's left over, one of these would be considered positive, one would be considered negative. When you added them together numerically, therefore, they would get smaller. Okay, so they would get smaller. Now the leftover, see, blue is longer than red, so the leftover vector, the resultant vector, would be this green arrow. That would be to the left. So the net force or velocity or acceleration would be to the left, but it would be much smaller than the other 2. Now, if we're in multiple dimensions, this piece of paper, this screen in front of you is 2-dimensional. You can go down the paper, you can go up the paper, that's 1 dimension, or you can go left and right on the paper, that's 2 dimensions. If you do some combination of those 2 things, then you can go down and to the left, or you can go up and to the right. That's working in 2 dimensions. Alright, so here, if we're adding in 2 dimensions, we are always going to use, for simplicity's sake, the head to tail method. Head to tail. Now, the head of a vector is the arrow head, and the tail is the other side. So whenever you're adding 2 vectors, you are going to place them one after the other, head to tail. Now, they've done that for us here in these 3 examples, and they're asking us to figure out what's the addition that's being done and what's the resultant. Okay, the resultant is going to be the straight line from where you started this whole thing to where you finished the whole thing. What you want to look for to determine what's being added, you want to look for head and tail. So we're adding C to B, and therefore we're getting a resultant of A. So we would have started the whole drawing here, we would have ended the drawing here. Our resultant would have been the straight line vector from where we started to where we finish. So the resultant is A. We're adding C plus B, we got A. The overall direction of the resultant, use your protractor as we showed in guide sheet 1, and measure and record compared to 0 being directly to the right and counterclockwise from there. You're going to get about 20 degrees. Okay, and this would be 0 degrees. We'd sweep the protractor here, and that's going to be about 20 degrees. Okay, and the next one, again, you want to look for head to tail. So you want to look for where you have the head of one vector to another. This one would be B plus C equals A. So again, A is the resultant. This time you put the protractor along this line like so, and you measure the angle. It's going to be beyond 90. You're sweeping again from 0, so it's going to be around 168 degrees. And the next one, our head to tail, is right here. So we're adding A plus B. And that means we're getting C. This time the resultant is C. And here's where it starts, here's where it finished. You want to put the protractor like so. center of the protractor here, and measure the angle. And again, coming around from 0 being straight to the right, you're around 19 degrees, depending on how carefully you measure it. Okay, here we have 5 different vectors. They just want us to show what the addition of each of them would look like. We don't have to draw them to scale at this point. We're going to get some idea of what they would look like if we added them together. So if I'm adding A, I would start with A, drawing a vector to the left. Then from the head of that first vector, I would draw B. Now, one of the things you've got to be careful about is make sure you get your protractor always lined up north and south. Okay, don't line it up with the vector. Always line it up with 0 degrees when you're drawing these. At this point, we're not drawing anything to scale, so it's not that critical, but when you start doing that, make sure you line the protractor up correctly. Again, not to scale, so I'm going to shorten D down a little bit so it fits. It's going to look something like this. Again, head to tail, head to tail. Then our resultant is, again, always the vector from where you started to where you finish. I started the whole thing here. I finished the whole thing here. So my resultant vector would look something like that. Okay. So now we're going to add A, come across to the left. C is straight up. D is over at an angle to the right. Again, the resultant is always from where you started, and I started here, to where you finish. Straight line vector, like so. Then we get to the next one. We're talking about B first. B is up and to the left. Then we're going to go straight up for C. And then we're going to add vector E, which is straight over. And our resultant is from where we started, here, to where we finish, here. Straight line. Okay, so one of the things you're definitely going to want to have when you're doing these is a straight edge. Ruler or the edge of the protractor to help you draw the line straight. My line should be straighter. It's just hard to draw on the computer like that. We're not drawing to scale at that point, so I'm just sketching out, placing each vector head to tail of the next one. I can think of it as elephants in the circus as they march down the street. The trunk of the first one, of the second one, attached to the tail of the one in front, and they're just going to make a big long line. Same thing, no matter how many vectors we add, it's just going to be head to tail, head to tail, head to tail, head to tail, until we reach the finish point. And then the resultant is always from where you started to where you finish. So that is how you would add vectors in a two-dimensional space. We'll look at more details in the second video.